All right, so you guys took some notes in chapter 7 over this energy, Planck's constant, and wavelength formulas. So I've got a few practice problems and then an assignment over it, but I wanted to work some practice problems just to make sure that you've got it and you understand it. But again, from the notes, here are the formulas that we're kind of looking at. We may need this. Remember, c is the speed of light, lambda is wavelength, this is frequency, E stands for energy, H was Planck's constant, and that was equal to 6.626 times 10 to the negative 34th joules times second. That was a constant number that would be provided to you. And then down here we have another formula that was lambda, again wavelength, is equal to Planck's constant divided by m, which is going to be mass later, and then v is going to be velocity. So these two are different than this. This v is velocity. The other one is that nu that I talked about, and that's frequency in that formula. Okay, so on number 1, it says calculate the energy of a photon if it has a frequency of 8.5 times 10 to the 14th hertz. So again, we have frequency and we need to find energy, and Planck's constant is a constant. So as long as we have frequency, we can just use this equation. We got to find E. So it's going to be the H, which is 6.626, times 10 to the negative 34th, that's joules per second. And we just got to multiply it by the frequency. And that is 8.5 times 10 to the 14th. Now, what I didn't maybe explain enough is hertz is the same thing as saying cycles over seconds. Same thing, and then which seconds are on the bottom, so that means it's seconds to the negative 1. So if you think about it like that, you could say seconds to the negative 1, and what happens is those seconds are going to cancel out, and what you're left with is joules, and that's the unit for joules. So we got to multiply these. Again, I'm going to kind of treat this like you do not have a graphing calculator and how to solve it following your scientific notation rules. So we're going to multiply the 6.626 times the 8.5. We need two significant figures. So I got 56, if I round that correctly. And then we've got to figure out our exponent. Again, we're multiplying numbers, so we add the exponents. So negative 34 plus 14 gives us negative 20. The only problem is, and I cannot write these in the right when I'm looking over my camera. So it's 10 to the negative 20. So I need to put this in correct scientific notation. So I'm going to move this 1 to the left, which is adding 1. So my final answer would be 5.6 times 10 to the negative 19th. And again, the only unit that hasn't canceled is joules. So I found energy. So there's the answer for number 1. On number 2, it says calculate the energy again. So we want to use the same formula, but this time they gave me a wavelength. That's where this top formula comes in up here, because we have the wavelength, but we need the frequency. So we're going to have to use this formula first to figure out what the frequency is. Again, C, I'm going to kind of write it up here. C is also a constant. It's the speed of light, 3 times 10 to the 8th meters per second. So this is going to be 3 times 10 to the 8th is equal to our wavelength, which is 6.4 times 10 to the negative 7th. As long as it's meters, you're okay. If not, you are going to have to make that conversion to get to meters. And then times V, or nu. So again, we're going to divide here to get rid of it on this side. So we're going to divide over here. So 6.4 times 10 to the negative 7th. So divide your numbers. 3 divided by 6.4 gives me, I need, looks like 2 significant figures. So I'm going to say 0.47 times 10 to the, I've got to say 8 minus a negative 7. Well, that's going to be a positive 15. Again, put this in correct scientific notation. Move it 1 to the right is saying negative 1. So this is 4.7 times 10 to the 14th hertz. Again, I haven't solved the problem because they're saying calculate the energy. So I had to get frequency, so then I could go over here and use the formula that I used up here in number 1, which is energy equals H times the nu. So 6.626 times 10 to the negative 34th joules per second. I'm kind of working it just like I did up here. It's Planck's constant times the frequency that I just calculated of 4.7 times 10 to the 14th. Hopefully you guys can see that, times 10 to the 14th. Again, it's hertz. I can also say seconds to the -1, meaning those units are going to cancel out. So I've got to multiply my numbers here. So 6.626 times 4.7 gives me, I need two significant figures. That's 31 times 10 to the -34 plus 14. I'm adding my exponents is -20. Then I just need to fix this and move it one to the left. That's adding an exponent. So that's going to be 3.1 times 10 to the -19th, and the unit is going to be joules. So there was the first type of the problems that I worked in the notes. I just wanted to work a few extra to make sure you guys understood it. And then the last one, it says, what is the wavelength for an electron that's moving at 2.42 times 10 to the 6th meters per second? That is a velocity right there. So if it's a velocity, that means I'm dealing with this last formula up here. And they want me to find that wavelength. So they want me to find lambda. That's going to be taking Planck's constant divided by the mass times the velocity. So to find lambda, I'm going to say 6.626 times 10 to the -34th. Now, before we go any further, I want you to kind of off to the side. I'm going to flip over to the back side. But we've got to look at our units here because, again, lambda is wavelength. It's going to be meters. H is Planck's constant. It's joules times second. But in the notes, I kind of talked about this. We need to treat this like kilograms times meter squared over seconds. It's the same units there. And then M is going to be mass, which is going to be in kilograms, and V is going to be in meters per second. If we try to write joules per second, we're not going to see what units are canceling. So I'm going to be writing it like that when I look at the H now. So flipping back over, that means this is going to be kilograms times meters squared over seconds. I'm going to be dividing this by the mass, which they tell me is of an electron, 9.11 times 10 to the -31st kilograms. And then I'm going to be multiplying that by the velocity, which is the 2.42 times 10 to the 6th meters per second. So if we look at all of our units here, kilograms here will cancel with kilograms there. Let's see, seconds are going to cancel with those seconds. This meters is going to cancel with one of those. So the only thing that's left is this meter unit right there, which that's what wavelength is measured in. So we have a meter left. So now we need to solve this. Again, if you have a graphing calculator, you can plug it all in there. I'm going to keep solving it like you guys don't have one, so you kind of see. So I'm going to go ahead and multiply these two numbers and get what the bottom is. So I would be taking 9.11 times the 2.42. And that gives me about, if I look at two significant figures, it's going to be 22.0 times 10 to the, I'm going to say -31 plus 6. That's going to be -25. So I'm not going to put it in correct scientific notation because I have another step, but I'm going to go ahead and move up here. So I've still got this top number, the 6.626 times 10 to the -34th, and I've got to divide it by, I've already multiplied these together, by 22.0 times 10 to the -25th. So I'm going to take 6.626, I'm going to divide it by 22. I need three significant figures, so that's going to be 0.301 times 10 to the -34 minus a -24. And that's going to be, I think I did that wrong. -34 minus a -25. I did that calculation wrong. So that's going to be -9. But again, this is now that I'm putting it in my final answer to get my wavelength, I need to move it one to the right to get correct scientific notation. One to the right makes it one more negative. So that's going to be 3.01 times 10 to the-- and remember, the only unit left was meters. So again, I feel like if you're strong with the math, you're going to be able to do this. And I just wanted to work a few more problems with you. There is an assignment over this. I have 3 problems that I want you to kind of work and make sure that you understand how to set these up on your own and work through them. So your assignment's attached in the Google Doc for today. Thanks.